The global transition away from fossil fuels presents a $1 trillion opportunity for energy technology providers. Delivering reliable, baseload power cleanly is a key element where new innovations can make an impact and presents as a big opportunity for any provider that can deliver. Geothermal power has a potential to meet this need, but right now it requires hot temperatures to make projects viable, leaving a vast number of lower temperature renewable resources completely untapped. We are ThermalX Engineering, a company focused on disrupting low temperature power generation by delivering clean, reliable baseload electricity at much lower temperatures than what is currently possible.
Our business model is simple. We deliver optimized industrial scale power generation solutions for our clients, and they pay us based on the size of the system that they need to be delivered. For our beachhead market, we are staying local in Australia and New Zealand, where we can focus on establishing our reputation, our product, and our service offering. We know that if we can demonstrate and refine our technology locally, we can push beyond our beachhead market into tackling global geothermal power generation projects at even bigger scales, and also push into other applications such as solar thermal and waste heat to energy. Due to the high availability of unutilised low-grade thermal sources, the global market for this technology is absolutely huge. Once we establish the low operating temperatures and increased output of our solution, we are confident that we can disrupt the market in a significant way. To deliver this disruption, we are bringing a step change in performance and value. We estimate that we can boost the efficiency of power generation at lower temperatures by up to 60%. For our customers, this means either significant savings for multi-million-dollar projects or increased profits. With our optimization technology, we expect to deliver an equivalent output power at 20 degrees lower than the current lowest operating temperatures. This will make a dramatic improvement on the yields of existing sites and enable more sites to become viable for project consideration.
The ThermalX product consists of a power generation technology combined with an optimization process. We call this piece our thermal booster, and based on our research so far, it is unique. We've developed a novel way for heat to perform the act of a compressor within a heat pump cycle. Our tech leverages this process to extend the difference in the used working temperatures for power generation. Because with these power generation systems, higher temperature differences relate to higher efficiency of power generation. Our booster can be built with off-the-shelf components, and we are currently drafting a provisional patent application to secure this key IP. Our product is the combined thermal booster and power generation equipment, which will be installed and commissioned for every project. Our competitive advantages will be the first-of-kind technology that improves power generation yield and boosts profitability. Baseload power generation when compared to other renewables such as wind and solar, and improved return on investment for comparable projects. We'll get there in the end. We've held a range of conversations across the spectrum of relevant parties, and what we have learned has been very insightful, as well as confirming of our product's market potential. We learned that our clients are frequently driven by the direct economics of a project. However, in contrast, there are also customers willing to pay a premium for energy that is both highly reliable and renewable.
We expect to reach a $10 million profit from 30% of our beachhead market. And our key drivers are market share, project size, and product margin.
Delivering clean baseload power means we can reduce our reliance on coal and gas. If we achieve 30% of our beachhead market, this is the equivalent of reducing our CO2 emissions by more than 300,000 tonnes each year. Our team, while still small, is dynamic in the skills that we bring, with experience covering engineering, research and development, multiple kinds of startups, sales, pre-sales, commercial and business strategy, industry collaboration, business operations and product management. We are both collectors of experience and skills and value a challenge. Our motivation and goals are are captured on this slide. Thank you very much for your time, and we look forward to your questions.
I might ask the judges to ask some questions and take a little bit of just a very brief break so that you can fill out your forms from the first pitch and the second pitch. So go ahead, you've got
Thanks.
3 minutes.
Thanks. So I'm really familiar with traditional geothermal, and I know it only works in a very, very small area of the world because you need that very high geothermal gradient. So what you're saying is your method is applicable in areas of lower geothermal gradient. So what is that as like a multiplier of the normal, compared to the application geography of the normal one? Because the thing with the lower geothermal gradient, it's just cold fluid.
Well, cold is relative. Okay, so aquifers in Australia can generate temperatures that are verging on what our system can generate electricity for. So even water supply systems for town centres come out hot in many, many different places of Australia. So our system could leverage some of those temperature that are shallow geothermal or shallow temperature environments.
All right, so let me just repeat my specific question. So if you look at the geography where you can use the traditional geothermal, it's very limited, right?
Very volcanic.
Exactly, in other places. How much broader is the geography of your application compared to that?
Much, much more broader. So a lot of this, considering just looking at Victoria, there's at least 2 different aquifers we can tap into or existing bores that make sense. Looking at different states in Australia, we can probably tap into a lot. Queensland has a lot of higher temperature bores as well that already exist. So a lot of this process reduces the cost of actually that initial exploration and enables that tapping into that existing heat source to actually deliver it. And the yield is much lower than what you would get from a traditional geothermal. So when traditional geothermals operate, they tend to operate above 150 degrees. That is the temperature range that is there, but they do have existing ones that go much lower. Normally they bottom out at about 100 degrees, but we're looking at pushing the boundaries of that to more than 20 degrees or even more than that lower. So we can extend the range of what's possible in that space. Not sure exactly of all of the geological sites that we would be able to address or expand to, but when you open that up, it opens up significantly with the amount that you can tap into.
I think we've got time for one more question and one quick response.
Have you done a pilot?
No, our technology level is fairly confirmed concept. So we're looking to next stage progress that to a lab-based test run. And then we've had some early stage conversations about getting some of these test cases in a real world scenario, tapping into some of these existing bores that are already in place. So still early days and started this process very much as an idea, and we're amazed that we've gotten to what we see as a very, very viable concept.
Wonderful, thank you so much. Big round of applause. Now, while we